Well, we're at the Port Townsend Foundry. We're going to go in and see Pete and Kathy and find out what's up. Maybe they're doing some casting today, which would be great. Hey, Kathy. That's me, Kathy. How you doing?
I'm doing fine. You're filming, aren't you?
I am filming. It's okay. What's happening here? All right, you're good. See what's up. How you doing? Cool. There's the old furnace, eh? So they're getting ready to do some castings with aluminum nickel bronze. I'm not sure what parts they're casting. Are these turnbuckles? Toggles and jaw ends, okay. How hot will the metal get when it's ready to pour?
Roughly 2,000 degrees.
2,000 degrees? Yeah. That's cool. That green flame I see coming out, what is that? Why is it green?
It is just part of the propane as it's burning off.
That's pretty neat. Cool color. Yeah. And we're going to talk about Martha's new turnbuckles, and he'll walk us through the process of how that works.
Hi Robert, it's good to see you again.
Good to see you, Pete. Yeah.
As you can see, here's some patterns. This is the basic one-off molding pattern for creating the turnbuckle body. It's called a split pattern. Again, it's been done with draft, shrinkage, overprints on the core prints, vertical core prints. It's also been calculated for a shrink rate, and also will have eventually what is called a core master. The core master is, for some people, this is the Coca-Cola inside the Coke bottle. So this being the Coke bottle, eventually this will be made in sand, placed inside our mold, and allowing the metal to flow over it, creating a hollow cavity. Narrow diameters are for the threaded sections of the turnbuckle, larger diameters for the threaded bodies to be able to clear and have free passage inside the bottle screw. So what we do first is create our core master. We move into making a core box, which is a two-part urethane castable plastic that is cast off of the core masters. These are then drafted again to be made into a pattern. So we take these patterns and then cast them into an aluminum casting, which now converts what is called a cold box process for making cores into a hot box process. The hot box process allows us to do cores that have holes through the center of them, so that as the metal wraps around these cores, the binder and gas created by them is then vented out the end, which allows for a much cleaner and more sound casting throughout the process. So these processes, the core boxes fit together and eventually are heated to about 350 degrees to 400 degrees. Sand is actually vibrated into the inside and allowed the excess to be dumped out. And as you're working these are obviously worked hot until you can get the final core to come out, be baked, and degas completely before it's set into the mold. And we'll go over and take a look at a mold that's open now of a toggle.
Okay.
Well, here we have a particular mold that's open. We have what's called the runner, the base of the riser, the in-gate, which is a connection between the runner and the actual part, the cores that have been placed, which will cast both a vertical hole through the toggle as well as the clevis pin hole fitting to the chain plate. This is what's called the drag of the mold. This is what's called the cope. And as you can see, there's an insulated riser. There's what's called a sprue, sprue connection to the runner, which is actually designed like a choke or that shape of a funnel to slow the turbulence in the metal down. The in-gate allows the metal to flow in and eventually up and out the vents. What we want is to make sure we have a continuous flow and up out the vents so that any gas or whatever is pressurized out of the mold, and we know it can be completely filled with good metal. Secondarily, then we have this insulated riser sleeve. As this part starts to cool, it contracts, and so it is using this riser as an insulator to maintain a volume of metal that is greater than the part inside, so as it cools, it draws that metal into the part, making a void or defect in here, which is engineered not to be in the part.
Excellent. There you go.
As you look at the sprue, being that it's a square shape, I'll turn and set this mold together. This also being the cope, again, will slide onto the mold. Now that it's set down together, you can see the sprue, which is the square portion of the mold. That's where the metal will be poured in. The risers where it will fill up and eventually fill, venting of any gas and excess metal to keep it flowing around the cores will come up through there. One of the good phenomena is to understand in a casting, and the reason we have a square versus a round funnel in a sprue is that if you pour water into a funnel, you get a whirlpool. If we pour metal into a whirlpool, we're actually accelerating the molecules, which changes the temperature of the metal. So what we're trying to do with a square corner sprue is actually slow down the velocity in which the metal is actually running into that runner and then filling the casting.
Neat. So I guess we're going to pour some metal pretty soon?
Yep, we're going to get ready to pour. The guys are just getting suited up, and we'll be ready to pour a bunch more of the jaw ends as well as some of these toggles.
Neat. Well, we'll come back for that in just a few minutes.
Sounds great.